Hi everyone. We're going to go ahead and get started in just a few minutes. I'm going to let some more people trickle into the webcast and then we'll get started. Thanks. Okay everyone, I think we're a few minutes past our start time, so we'll go ahead and get going. Welcome to today's webinar on Integrated Municipal and Stormwater Wastewater Planning for Burlington. We're excited to get today's presentation started. Thanks for joining us. I'll be kicking off the webinar today and advancing the presentation for our speakers. My name is Emily Ashton and I'm an ORISE Research Fellow with the U.S. Environmental Protection Agency's Office of Wastewater Management. I've been at EPA since 2013 and my role in this project is to be the liaison between Burlington, EPA's contractor, and EPA on the Integrated Planning Project, which is the subject of today's webinar. Integrated planning is a comprehensive stormwater and wastewater management approach that communities might be interested in, and we are excited to have Burlington involved in this effort. So before we get to our presentations today, I'd like to go over a few housekeeping items. First, we'll have a short question and answer session for our live audience at the end of the presentation. To ask a question, simply type your text in the questions box on your control panel and click the send button. If your control panel is not showing, click on the small orange box with the white arrow to expand it. You don't need to wait until the Q&A period to submit your questions. We'll try to answer as many questions as possible at the end of today's webinar. However, not all questions may be answered, and we will try to follow up on the unanswered questions after the presentation. We will also try to compile all of the Q&A to be posted on the web for others to view. And the speaker's contact information for today will be available at the end of the presentation. If you have any technical issues, such as audio problems, you can call the GoToWebinar support number, 800-263-6317, and give the assistant our conference ID number, 100-527-211, and that's also listed here on your screen. So before we get to today's presentation, I'd like to run a poll. We'd like to see how many people are viewing this webcast, so I'm going to send this out right now. If you can just select your option, and then we'll get started with our presentation. Awesome. Thanks, everyone. So with that, I'd like to go ahead and introduce our speakers for today. Megan Moyer is the Stormwater Program Manager for the City of Burlington. Since 2009, Megan has managed Burlington's dedicated stormwater program. Prior to joining the municipality, she was a technical reviewer for Vermont's DEC's stormwater section and later the stormwater scientist for the State Center for Clean and Clear, which focus on implementation of phosphorus reductions in the Northern Lake. She holds a BA from Rice University and an MS in Water Resources from the University of Vermont, and is also a certified professional in erosion and sediment control and a certified professional in stormwater quality. Our other speaker today is Christy Williams. She is an environmental planner and has worked in the water resource and land use planning and policy field for 22 years. Christy has written publicly owned treatment works, MS4, and industrial stormwater permits, and conducted audits for more than 75 MS4s around the country. Christy has provided green infrastructure planning assistance to municipalities around the country, and specifically has assisted several CSO communities develop green infrastructure plans in order to comply with permit and long-term plan requirements. She has also worked as the MS4 program manager for a State Department of Transportation and a local county planner and stormwater program manager, an outreach and environmental program coordinator for a national conservation nonprofit, and as a stormwater and erosion control construction inspector and plan reviewer for several local governments in Central Virginia. Lastly, Barry Tunning is a senior water resources management consultant with Tetra Tech and works with public and private sector clients nationwide on stormwater, wastewater, non-point source pollution, and watershed planning issues. He is a graduate at the University of Georgia with a master's from Morehead State University. So I'd like to thank Megan, Christy, and Barry for joining us. And now I'm going to bring Christy on the line. Give me 1 second. Christy, are you there?
I am.
Okay, take it away. Thanks.
Good afternoon, everyone. Today for the webinar, we have 4 primary objectives. One, we want to provide you sort of a quick education about integrated stormwater and wastewater planning generally. Then we're going to give you a little background about why Burlington was interested in this approach and how it might be helpful to the city of Burlington. Then we're going to discuss how integrated planning could help Burlington address their challenges specifically. Megan will be going over that in some detail. And then at the very end, we're going to tell you about a variety of ways that you and other people can be involved in the public input process that is really important to the integrated planning overall process. Next slide. Just to give you a little bit of background about how we got where we are, U.S. EPA has a technical assistance program that the city of Burlington applied for, and they were one of 5 awards in the country. Basically, it's similar to a grant program. However, instead of having a financial funding award, there is an award of contractor assistance. So the company that Barry and I work for, Tetra Tech, will be working with the city of Burlington for the remainder of this year, helping them to sort of kickstart their integrated planning process. In doing so, we will try to help them address their stormwater flow and quality requirements, the wastewater treatment plant MS4 permit requirements, try to sort of start dealing with their combined sewer overflows to the integrated planning process, and then also, of course, the phosphorus reductions that are required by the Lake Champlain TMDL. We'll be working with them throughout the entirety of the project, and it's supposed to be finishing up at the end of this year. Next slide. Just to give you a little bit of background on integrated municipal stormwater and wastewater planning, in 2012, EPA issued a memo called the Integrated Municipal Stormwater and Wastewater Planning Approach Framework. The website is there on your screen, and you can also find a link to it on the Burlington Integrated Planning website, and that link will come up towards the end of the presentation. But basically, integrated planning is supposed to help municipalities achieve human health and water quality objectives that are in the Clean Water Act by helping them address both inefficiencies and efficiencies that are among various permit requirements that they might have. And one of the primary things that we try to understand through this process is how to make the best capital investments while complying with all of the various permit requirements that may exist. So it consolidates a lot of goals and priorities into one planning exercise, and these things are summarized in a integrated plan, and the framework for that is actually outlined in this memo. Next slide. The planning framework memo actually describes the elements that EPA encourages to be included in a sort of a written document, a planning framework that would be developed by municipalities interested in doing integrated planning. And the elements are listed on your screen. They first want a description of all of the different issues that are to be addressed by the plan, and this includes a variety of water quality issues, both permit-related perhaps or TMDL-related, human health, other regulatory issues that might be related to CSOs, anything, I&I issues, wastewater treatment plant issues, TMDL issues, MS4 issues, which is a municipal separate storm sewer system permit issues. They want you to describe your existing systems and the performance of those systems. They strongly encourage there to be a strong communication and community input process, of which you are officially a part of by listening to this webcast. And also a process for identifying, evaluating, selecting, and implementing projects. And those are sort of the two components of the planning framework that we are addressing and discussing today. Later on in the webinar, we'll talk more in detail about how we're going to try to help the City of Burlington develop a process for evaluating projects that will be implemented by the city. And it's important to remember that one of the key focuses of that process will be cost effectiveness. In other words, the city will be able to provide in the framework a financial capability assessment as one of the rationale behind the selection process that the city decides to undertake for selecting projects. The last two items that the memo suggests be a part of the framework are success measures, and this could include actual water quality monitoring, BMP type monitoring, in-stream monitoring, ambient monitoring. It could also be the development of performance indicators that may not specifically be tied to water quality assessments. So there are a variety of things that could be used for success measures. And then there needs to be some sort of a process described about how this framework will be adaptively managed. In other words, there needs to be some sort of a system in place to be able to assess the success and the effectiveness of the plan to see if it's working and then adapt it if it's not. Next slide. EPA believes that there are a number of benefits to attempting to use the integrated planning process. We've kind of touched on a couple of those, but obviously you would want to maximize your municipal resource use, and that would be staff time as well as financial resources, while also complying with regulations in the most financially realistic way, and then optimize the benefits that all of the projects that you might want to undertake would actually achieve. It would also enhance the options for improving water quality. The memo specifically encourages using green infrastructure projects, assessing their effectiveness to achieve the goals that the integrated plan framework sets out. For example, nutrient trading might also be another sort of alternative option that could be utilized through this process as well in order to comply with water quality objectives. And it does not only accommodate but encourages flexible sequencing and scheduling. So it tries to allow municipalities to schedule certain projects not only based on sort of permit compliance schedules, but based on when they're financially capable of completing the projects and maintaining the projects, and for sort of achieving the most bang for the buck, so to speak. But while doing all of these things, the planning process does intend to maintain compliance with all the Clean Water Act requirements that a municipality might be facing. Next slide. But of course, it does come with some challenges. The idea of trying to integrate a lot of related but often very different permit requirements or water quality challenges that a community might have. While they're interrelated, they also are quite complex. And when you're considering multiple goals, multiple stakeholders, multiple drivers, which could be quality, quantity, flood control, other sort of ancillary benefits that folks may want to try to realize with these projects in addition to a stormwater or wastewater benefit, in addition to the cost, of course, and then trying to wrap that into the asset management requirements that any municipality has just generally, it can be quite a complex undertaking. So with that, I will pass it off to Barry to get started talking about a few of the more specific details of integrated planning.
Okay, thanks, Christy. Hopefully everyone can hear me. I wanted to just give you an example of something Christy just mentioned during her presentation. She talked a little bit about the complexity of the issues and multiple goals. This is a graph here that kind of lays out a hypothetical example that integrated planning might address. You see here on the slide, this is a graph. On the horizontal axis, you have time in years from 1 to 10 years. On the vertical axis, you've got percent improvement in water quality. So as you go through time to the right, increasing water quality, better water quality as you rise up on the vertical axis. And then across the top, you see the dotted line, numeric water quality standard. Now, this may be an actual numeric standard for chlorophyll A or for nitrogen or phosphorus. It may be some kind of surrogate standard. But in this hypothetical example, a municipality, a group of water resource management people might be faced with some challenges in reaching that water quality standard or that surrogate measure of improving water quality. And there may be a number of options on the table. In the red, you see the water quality results from an upgrade to the wastewater treatment plant. In the green, on the green line, you see implementation of a green infrastructure program over many years. And the blue curve on the graph represents an ag nutrient trading program. You can see as the time goes by in years, you may get real quick results on the red line. You may increase water quality by 30, 35% or more with the wastewater treatment upgrade. But once you've done that, your water quality improvements are fairly static after that if that's the only thing that's done. With the green line, the green infrastructure program, the rollout is a little bit slower. The realization of water quality benefits is a little slower, maybe 3, 4, 5 years or more, depending on what's going on. But you can see that over time, after 4 years or so, you're getting more water quality benefits from a comprehensive green infrastructure program than you would from the wastewater treatment plant upgrades alone. So the green infrastructure piece, that approach will get you better water quality benefits over time. Not as quick as the wastewater treatment plant in the first few years, but certainly better results over time. And lastly, the blue line, the ag nutrient trading program, that may have an even slower rollout, maybe almost indiscernible benefits for the first 3 years or so. But after time, the program might start delivering benefits that exceed not only the wastewater treatment plant upgrade, but the green infrastructure program as well. So this is a hypothetical example of a scenario that might play out for a municipality and the water resource people that are involved in that municipality in considering how to improve water quality when you've got a basket of potential solutions that may range from wastewater treatment upgrades and stormwater program components all the way through to agriculture policies. And I did want to mention that, as Christy did, that integrated planning can include other areas, including non-point source pollution control, nutrient trading, and source water protection programs. So there's a fairly broad charge, and it's going to vary quite a bit depending on the municipality. It will be very unique in each case in terms of whether the integrated planning approach is going to involve just wastewater and stormwater that the municipality is involved in, or whether or not there are opportunities outside that that may result in better receiving water quality over time. On the next slide, you can get an idea of where we are in this process. This is a pilot program. As Christy said, the framework was just signed a few years ago. The 5 pilot projects that Burlington is a part of are just starting into this, and our orientation webcast today is meant to introduce people to the planning process and where we are and where we'd like to go in the near term. This is very much focused on the stakeholder involvement piece of the framework. And as you can see there, it's very similar to a watershed planning approach. The idea is to develop goals and objectives for the process, identify projects which would contribute to those goals, and then to develop a considered way to use data and information to evaluate the projects. And I'll talk about that more here in just a minute, but that is very much what we're focused on over the next few months, to develop a set of project evaluation criteria that Burlington people can use to evaluate projects, whether they're wastewater, stormwater, or other projects, and see if there are some benefits for one set of projects over another using a set of evaluation criteria that are derived from stakeholder input. On the next slide, you can see that this is very much like the watershed planning approach. It is an iterative process, involve stakeholders, build partnerships, define your goals and objectives, look at the receiving water body and water quality, identify what's needed to improve water quality in the receiving water body if that's necessary, and then to go through a process of identifying potential structural and non-structural projects, which may involve, again, wastewater treatment plants, the stormwater program, maybe some non-point sources depending on each unique local situation. Evaluate those candidate projects and implement those, evaluate what's happened in terms of water quality, and then go through your adaptive loop and go through the process again. On the next slide, you can see some specific issues and applications that may come to bear in Burlington during this process. Megan Moyer, who will speak after me, the Stormwater Program Manager in Burlington, is in the process now of engaging stakeholders. She's been going to some of the Neighborhood Planning Association meetings, and I understand that she's also going to be talking to some of the front porch forums. There's been at least one article, I believe, in the news media, but we are engaging stakeholders now on this first piece to select and prioritize criteria for assessing proposed projects. And there's a sub-bullet list there of potential projects that Burlington is looking at now. Everything from stream flow restoration projects, combined sewer retrofits, green streets, phosphorus reduction opportunities. It might be erosion control. It might be reduction of stormwater volume through infiltration. Lots of options there. Also, sewer separation and potential storage. Nutrient trading with the ag sector has been mentioned. I know there's been some discussion about that throughout the Northeast and actually throughout other parts of the country. It's a big topic right now in the Midwest with the Mississippi River Basin Initiative and the Gulf Hypoxia Task Force, and also wastewater treatment upgrades, and there may be others. So there's quite a range of things on the table that are being considered. On the next slide, you can see what we're hoping to do, generate some input from the public, from stakeholders in and around Burlington to understand what the primary concerns are, to come up with some goals, and to identify, characterize, and rank potential project evaluation criteria. On the next slide, you can see what some of those might be. We are developing a process to solicit input on that will include some direct interaction through Megan's presentations, possibly online surveys and other tools. But some of the potential evaluation criteria could be various costs, capital costs to implement a project, operation and maintenance costs and so forth. Also performance, does this project reduce peak flows like we thought it would? Are we achieving the kind of pollutant reductions we thought we would? And those two factors are pretty conventional for stormwater and wastewater projects. How much does it cost and what's it going to get me in terms of performance? But communities have come forward many times and said that they have other issues they'd like to be considered, other potential project evaluation criteria. And they may include things like construction impacts and noise. They could include aesthetics. Sometimes people don't like the way things look. They don't like where they are. Sometimes they like for projects to be coupled with other things going on, maybe development of a walking trail or development of a park. So that's what we're about here, is to try to solicit input from the community on not only the conventional project evaluation criteria, but also other things that the community might be interested in. On the next slide, you can see an even more detailed list of some of these, and I don't want to get into the weeds too far with these, but for people who are interested in this process and who are willing to take a short online survey or go to some of the events that Megan will be appearing at over the next couple of months, these are some of the things that you'll see. There's a universe of project evaluation criteria that might be on the table, everything from performance and cost to things like the efficiency of the project. If you're trying to reduce phosphorus, for example, for improving lake quality in the, Lake Champlain, there's some cost per pound analysis that could be done. If you're concerned about climate and extreme weather events, operational resilience might be a big factor. And then on the right-hand column there, lots of other things that we could consider. Does this help the green space or the green infrastructure side of what's going on in Burlington? Traffic calming, is this a sustainable solution, or is this something that's going to need to be replaced frequently? Are there high energy uses associated with it? Are there economic benefits and so forth? So just an example of some of the potential project evaluation criteria that you might see and might be asked about as this process rolls out. I'm now going to turn it over to Megan to talk a little bit about some of the stormwater and other issues that Burlington is considering now in this integrated planning process.
Thanks, Barry. Thanks to both Barry and Christy as well as Emily for putting this webinar together today. I'm really excited to be talking to the public about what our plans are. As most of you who are listening know, as Vermont's largest and most urbanized city, Burlington does have numerous water quality and water infrastructure challenges. It goes without saying that I'm extremely excited about the prospects of integrated planning, but it also goes without saying that it can be very overwhelming, and I find it overwhelming at times to look at all of our issues. And this sort of word cloud is a map of what my brain looks like on a good day. So I'm extremely appreciative of the help that EPA and Tetra Tech are providing with us to give us some guidance and frankly, a little bit of hand-holding in this process. So the next few minutes I'm going to spend orienting all of you to some of what I view as our biggest and most persistent water quality challenges or water resource challenges. And then we'll return to talking about how the project evaluation criteria might help us figure out the sequence of stormwater and wastewater projects based on the criteria that Burlingtonians and other water quality stakeholders will hopefully help us develop. So on the next slide, this is a map of a somewhat complex sewershed/watershed arrangement. We're going to start off today talking about the issues that are specific to the combined sewer areas of the city. So those, if looking at the legend, the main plant sewer shed shown in purple in the core of the city in the downtown, the bits of pink in the new north end which drain to North Plant, and the other smaller lighter shades of pink which drain to East Plant, which discharges off of Riverside into the Winniski River. So while the city is much less combined than it was in the 1980s, about a quarter of the sewered area of the city does still drain into a combined sewer. And the main plant combined sewer shed in particular has some of the highest percent impervious in the city, just calculated it recently, and it's over 50% on average across the combined sewer shed for main plant. Next slide. So combined sewers, again, just to bring everybody up to speed, combined sewers are very typical of older communities throughout Vermont as well as the nation. Whereas in newer parts of the city where there's a separate pipe for sanitary sewage and a separate pipe for stormwater runoff, in the combined sewer there's unfortunately only one pipe. This works okay during dry weather, as you can see on the left-hand side of the photo. And during, I would say, small rainstorm events where the combined sewer mixture of sewage and stormwater runoff reaches the treatment plant and basically receives full treatment. However, what happens during larger, more intense rainstorms like we've been getting, two things can happen. The first is sometimes the volume of combined sewage, again, a mixture of stormwater and wastewater, is so great that it can't fit through the pipe network. And while we've invested millions of dollars, first in the 1980s and more recently in the 2010 to 2012 period, to eliminate combined sewer overflow points and also reduce the frequency of overflows, we do still have 4 locations throughout the city where there are these release points where combined sewage overflows occur. Right now, there's 2 off of Manhattan Drive that discharge into the Intervale wetlands, one that is at the end of Gazo Ave, which discharges to the Winooski River, and one at the bottom of Colchester Ave, which also discharges to the Winooski River. The other thing that happens is for the combined sewage that does reach the plant during very large storm events, while the combined sewage does receive the maximum physical separation of solids and disinfection prior to discharge, some of the combined sewage that's above the 13 million gallons per day flow bypasses the nutrient treatment processes of the plant. So this component is actually generating more phosphorus because of the fact that it's mixing with the sewage. Neither of these conditions are desirable. Unfortunately, the typical manner of eliminating combined sewers in the past has often been to pursue sewer separation. And generally speaking, sewer separation has not typically provided for treating the stormwater runoff once they put it in a separate pipe. As we all know now, stormwater runoff also has very many pollutants. And in many cases, there are also space constraints. So people have room to do a new pipe, but they don't necessarily have room to do a large-scale treatment practice that would then treat that stormwater runoff. So for that reason, many communities, including ours, are thinking about the benefits of maybe infiltrating and storing stormwater within the combined sewer areas versus spending the larger amount of money just to put in a new pipe that's going to actually potentially pollute our waters even further. Next slide. Oh, and back to the other slide, just if anybody's interested, we do monitor all of our combined sewer overflow points, and we do report our overflows as required by our permit at the state website. So if you're ever curious if one has occurred after a rain event, we do have 24/7 monitoring and immediately report those overflows when we know that they occur. Okay, next slide. So the other thing that has occurred from time to time during extremely large rain events is the basement backup of sewage. So this often happens in this always happens in areas of the combined sewer system where there's low-lying homes and/or homes that have plumbing fixtures in their basements where they haven't installed backwater valves that are actually required by the plumbing code. So essentially what happens is kind of like a combined sewer overflow. If the elevation of the toilet, sink, or washer connection in the basement is lower than the elevation of the manhole in the street, and the flow of the combined sewage is too much for the pipe in the street, it's going to seek the lowest point of relief. And this has, most recently in 2013, resulted in both residential and commercial basement flooding of combined sewage. Despite our recent efforts at educating the public regarding the importance of backwater prevention valves, the threat of this basement flooding does still exist for any unprotected home. We've put together a series of fact sheets that are available at the link there on the website, but we do recognize this as another issue that we would like to see addressed throughout the community. Next slide. So moving on from the combined sewer, we move towards our other sort of special watersheds, the stormwater impaired watersheds. We have Burlington drains to 3 stormwater impaired watersheds, Inglesby Brook, Centennial Brook, and Potash Brook. And these are streams where the state, through monitoring, has deemed these streams to be overwhelmingly impacted by stormwater runoff. Next slide. I'll say in the old days, I guess in the 1990s, early 2000s, scientists originally thought that these streams were being affected by the sediment runoff and the runoff of pollutants to these streams. But they eventually determined that one of the main issues that was causing the stormwater impairments was the excess volume of stormwater that actually was causing in-stream habitat degradation. So the amount of water that hits these small urbanized streams is so high that the stream bed is eroded and scoured, and the aquatic life, the macroinvertebrate bugs and fish, just simply can't survive. And because we don't have the bugs and the fish, these streams don't meet Class B water quality standards, and we're required to go through a process to try to reduce the flows for these various streams. Next slide. So in the case of Inglesby, Potash, and Centennial, the state DEC has set flow reduction targets and TMDLs for each of the streams, meaning that we actually have to go through a process where we model placing various stormwater retrofits across the landscape to reduce that excess runoff. Ideally through infiltration or runoff reduction practices, but in a lot of cases it's ending up that we have to do detention practices. These flow reductions range from 18% flow reduction for a place like Potash to about 34% for Inglesby, and about a 50% reduction in high flow for Centennial. So the interesting thing is whereas stormwater management regulations traditionally only target larger new development and redevelopment projects, these flow reductions and restoration processes are actually requiring us to step through all of our existing impervious and evaluate the best opportunities for managing that impervious. And I know I'm using a little bit of jargon. A retrofit is simply going back to an area that's already been developed and trying to figure out how you cram in various types of stormwater treatment where none currently exists. The slide right now shows we've actually completed the Centennial Brook, or close to completing the Centennial Brook Flow Restoration Plan as part of this process, which was definitely not easy and is not going to be an inexpensive endeavor. 40 retrofits were modeled. We are now proposing to potentially manage over 90% of the watershed impervious cover, and the total price tag for that effort is going to be in close to the $10 million mark. Of that slice of the pie, Burlington probably will be looking at about a $1.5 million investment. We're currently underway with the Inglesby Brook Flow Restoration Plan, and South Burlington is leading the Potash Flow Restoration Plan process. And while we don't have the final estimates, the total cost for Inglesby is estimated also to be in the $9 to $10 million range, largely because of the highly developed nature of Inglesby. And that price tag is going to largely fall, well, almost entirely on Burlington. South Burlington only drains, a very small part of South Burlington drains to Inglesby. We also will have a small slice of the pie for Potash. Don't know the exact percentage yet, but the total price tag for Potash is envisioned to be about $25 million. So you can see that the costs are starting to add up. Next slide. Some other issues that aren't maybe necessarily water quality focused, but are definitely at the forefront of many Burlingtonians' minds is the issue of localized flooding. We have an old system. We have pipes that were sized based on older rain events. And I think in the recent years, we've all noticed a general trend towards heavier rain events, both an increase in the number of intense events, as well as in the increase in the amount of rain that falls during those events. And if you haven't checked out the National Climate Assessment Report, there's some great graphics and data in that report kind of documenting what we're really seeing and showing that the trends are larger than what the just natural variations are, particularly for the Northeast. And in fact, as of 2012 compared to, I think, 1958, over that time range, there's been a 71% increase in the amount of rainfall that falls during these heavy downpours or the top 1% of daily rain events. What do we do about this? The pipes are small. Do we go through the process of digging them all up and replacing them with larger pipes, or is there a different solution that might get us a similar impact but provide overall better benefit? The other issue that we can't really change is that a lot of our outfalls, which discharge to the lake, are actually impacted by lake levels, and that's a challenge I'm not even sure I even know how to begin addressing. Next slide. Another issue which is a little less, I guess, known to the average public member because it's either subsurface and kind of out of sight, out of mind, is the issue of our aging pipes and our outfalls, which are being challenged by more and more high velocity events. We have about 53,000 linear feet of corrugated metal pipe, and as you can see in the upper left-hand corner, corrugated metal pipe does not work well with the salts that we apply on our roads to keep ourselves safe in the wintertime. So as we increase the amount of filming that we're doing, we're finding that, and this is on average because we have not looked at every single pipe yet, although we are hoping to do so, about 50% have some sort of structural deficiency when we look at these corrugated metal pipes which carry our stormwater flow. And we're finding that probably 10 to 20% need some sort of near-term repair. We're pursuing a pretty aggressive program of pipelining using the cured-in-place pipelining, so we don't have to dig up the pipes, but that is still a costly endeavor. On the end of the pipe, we have about 102 outfall areas, and based on our most recent assessment, we estimate that about 10% plus of those outfall areas are what we would consider failed, as is shown in the picture on the right, and many, many others are in very poor condition. These outfall failures have water quality impacts. There's a lot of sediment that's being generated once the riprap has failed and once the pipes have failed. And in some cases, we're getting close to affecting public and private infrastructure. Next slide. And lastly, but certainly not leastly, the Lake Champlain phosphorus TMDL. While we're waiting for the final revision, I believe is now potentially due in the July timeframe. And this is something we've been dealing with for a long time, but the revision is presumed to place more strict or stringent and more discrete requirements on the wastewater treatment plant and separate stormwater sectors. Just again, jargon buster here, the Lake Champlain TMDL stands for total maximum daily load, and essentially this is the amount of a pollutant that a water body can absorb or assimilate without becoming impaired. What we do know, I don't think this is going to change, is that the TMDL will require that the allowable concentrations from our wastewater treatment plants be reduced from 0.8 milligrams per liter of phosphorus to 0.2 milligrams per liter. And right now the state estimates that the cost for upgrading all three of our plants to achieve this concentration would be on the order of $38 million. We also know that we're going to be required to do extensive retrofits of our existing impervious surface to reduce stormwater, to reduce phosphorus loading from stormwater runoff, and we're also going to be looking at doing volume reductions in storage within our combined sewer system to try to reduce the phosphorus impact that I was speaking about earlier at the treatment plant. Next slide. So getting back to why we're doing the integrated planning process and why we need the public's input on how we're going to do this thing. So based on the stakeholder and also city staff input, we're hoping to choose a number of criteria and then also prioritize those criteria through a weighting process. And then ideally, we're going to be using those criteria to kind of point us in the right direction of where we're going to get started first. We need to decide which of our water quality or water resource issues are going to be the highest priority and might be addressed earliest in our implementation process. And then we're also going to really need help to address how we, to decide how we address these water quality challenges based on those criteria. I threw up a couple examples here, examples that I know that other communities have struggled with. When you look at the cost of building a CSO or a combined sewer storage tunnel, which, yes, will do the job and will store the combined sewage so that it can be slowly released to the treatment plant, millions and millions of dollars, subsurface has no other co-benefits. On the flip side, a lot of communities such as Philly and New York, DC, are looking at whether or not they could achieve the same amount of storage, or at least a partial amount of that storage, through green infrastructure, such as the bump out that is shown on the right, which is a bump out that's at the top of North Street. In the combined sewer system, this bump out allows stormwater runoff to infiltrate back into the ground and never reach the combined sewer system. And in really, really big thinking, I still wonder about the possibility of, if the numbers were verifiable and we could make our case, could we potentially, instead of upgrading our wastewater treatment plant technology, could we make the case to actually do more combined sewer or more separate stormwater retrofits? Particularly in the case of separate stormwater retrofits, my thinking is that wastewater treatment plant technology upgrades are really going to only be targeting phosphorus. And while, yes, the TMDL is targeted on phosphorus, there's a lot of other pollutants out there. And would it make more sense to go after a larger volume of stormwater treatment for all of that existing stormwater impervious or existing untreated impervious, and maybe grab a whole bunch of other pollutants which may not have a TMDL, but that doesn't mean that they're not important. So next slide. As Barry mentioned, we are kicking off with this webinar a long-term stakeholder process. This webinar is going to be archived and will be provided on our website, and we're hoping also to get it on community TV. Tonight I am starting off visiting the first NPA, or Neighborhood Planning Assembly, in Ward 6. We're going to be putting out email updates, and very, very, very importantly, hopefully next week we will be releasing a public input survey, which I hope all of you will participate in, so that we can kind of start the larger public engagement process. We're also going to be trying to reconnect with people on Front Porch Forum and social media, and we're hoping to do some integrated planning tours where people would be invited to come down to the wastewater treatment plant and also maybe take a look at some of our green infrastructure. And then lastly, we are going to have a number of stakeholder meetings where we'll be face-to-face talking about the information that we get from the public input survey and starting to develop those criteria. Next slide. So there's still a lot of information out there online. We have the copy of the memo and also a schedule of all of the events that we're planning available on our integrated planning website off of the stormwater page on the Department of Public Works site listed at this link. Next slide. And our contact information, if you want to have any follow-up questions. I don't know if we've had any questions come through on our chat box, but if you think of something, also if there's an issue that I didn't present as one of our larger challenges that you think that we should look at, you can feel free to provide that information. And I think with that, we can see if we have any official questions.
Thanks, Megan. This is Emily. So I went ahead and brought everyone back online if you want to go ahead. And there was a few questions. Barry, Christy, or Megan, if you want to talk about those, you can go ahead for that.
Yeah, I guess I could start up. And this is really a question for Megan. Just a basic information question about CSO events. The question was, for CSO events, where are the monitoring points? Do you monitor those CSOs at the end of the pipe, or is there another location where you monitor CSOs?
The CSOs are monitored right at the pipe, the overflow pipe itself. I see another question, which I'm not sure who it's from, but the thing that we report online is the untreated CSOs. The bypass events or the wet weather events that happen at the main wastewater treatment plant are reported on our monthly reports, which go to the state, because those are partial treatment events versus the CSO points. But we have, I think it's mission control, so you can go online at any, or we can go online at any point and see the duration of a CSO from our 4 points that we have. Does that answer your question?
Yeah, I think that was the gist of it.
Okay.
I'm not seeing any more at this minute. Did you have any additional questions, Emily?
No, we haven't had any more come in.
Okay, well, if we have no more questions, I don't know, Christy, if you or Megan or Emily have any final words. If not, we can conclude the webinar.
I don't think so, Barry.
All right. Well, thanks again on behalf of all of us for tuning in today. This webinar will be archived, and there will be a link and information about it on the City of Burlington Stormwater webpage. And again, please watch for the presentations and the link to the online survey. We really do need your input in this process. And Megan, you can have the last word.
I just want to thank everybody for this opportunity and everybody who attended. I really appreciate you taking the time. Pass on I guess maybe we'll try to send out the link to the archived webinar so that people can forward it onto their colleagues if they so see fit. And otherwise, I hope to see you out there at some of our public input events.
All right. Thanks, everyone. Have a good day.
Thank you.